Good afternoon, all. I am Padmapriya from Information Technology and from SNS College of Technology. Today, I am going to talk about or explain about the DAA. DAA, the Debug Design and Analysis of Algorithm, as you know all. In DAA, we are going to see about the topics of dynamic programming and greedy algorithm. So, what is dynamic programming? Dynamic programming is the core technique in DAA, which is nothing but solve the problems by breaking that particular problems in subproblems, and that subproblems can each and every subproblems can store that particular solutions for avoiding the redundant calculation, leading to efficient solutions. So in that, what are the key characteristics we have we are going to see in dynamic programming means for overlapping subproblems. What is overlapping subproblems? If we divide the subproblems into subproblems, they can used multiple times, we can reused. So in that case, the multiple single function can used in multiple times, means it will take more time. So for avoiding that particular solution, we are using dynamic programming, so that the problem can be breaking into subproblems. The particular subproblem solutions can be stored. The each and every solutions can each and every particular solution only can used any other time. We don't want to use the entire problems. We don't want to reuse that entire problem. So what is optimal substructure? An optimal solutions to the problem can be constructed from optimal solutions to its subproblem. If we find the if we find the optimal solution for particular subproblem, we also get some optimal solution for that particular subproblems also. So example of the example of dynamic programming is Fibonacci sequence. The problem of Fibonacci sequence is calculate the nth Fibonacci number, which means the two preceding ones starting with 0 and 1. The explanation of problem is, once we define the Fibonacci recursive function, if n is less than or equal to 1, we have to return the value of n. Else, if n is greater than 1, we have to add the value of before the exact value plus the same value. We have to add those things and return the value. This is the Fibonacci function. When we call the function, the entire function is called again and again. So avoiding that redundant function, we have to use dynamic programming. This is the Fibonacci sequence. So other example is knapsack problem and longest common sequence and matrix chain multiplication. Knapsack problem is determining the most valuable items to include in a knapsack, which means a knapsack is a particular kind of bag that bag can have the limited weight capacity. We have to add some kind of things in that bag based on the capacity. That is knapsack problem. So longest common sequence is finding the longest subsequence common to two sequences. So matrix chain multiplication means finding the most efficient way to multiply a chain of matrices. So what is knapsack problem? As we said before, the knapsack problem is nothing but states that you have a backpack with a weight limit and you are in a room full of treasures, each treasure with a value and a weight. That's nothing but a knapsack means it's a kind of bag that can have a limited weight. Into that bag we have to add some things or objects. Each and every object can have some value. Based on that your knapsack bag capacity, we have to add that objects in that bag. So once the weight is reached, we can't add any one more object to that bag. This is the knapsack problem. To solve the 0 by 1 knapsack problem, you must figure out which treasures to pack to maximize the total value and at the same time keeping below the backpack's weight limit. So this is the knapsack problem, and what are the rules we have followed in knapsack problem? First rule is every item has a weight and value. Your knapsack has a weight limit. choose which items you want to bring with you in the knapsack. So if we can have any objects weight is over more than your knapsack bag weight, we cannot take that objects. So this is the thing we have explained here. Choose which items you want to bring with you in the knapsack. You can either take an item or not. You cannot take half of an item, for example, which means if the knapsack bag weight is 1000 means if we add an object to the knapsack which weight is 500 means we have to add that objects entirely. We can't split that object value which is 500 into 250 and 250. So that thing here explained. You can either take an entire item or not. You cannot take half of an item, for example. Goal. What is the goal of knapsack problem is maximize the total value of the item in the knapsack. So solving the knapsack problem, it helps businesses decide which projects to fund within a budget. Now we can see where various types of business and entrepreneurs are doing their business based on their budget only. If the business proposal is exceed their budget, we can't run their business successfully. So this is the problem which that problem can be solved by this knapsack problem. So maximizing profit without overspending. It is also used in logistics to optimize the loading of goods into trucks and planes, ensuring the most valuable or highest prioritized items are included without exceeding weight limits. Thank you.